Morning. So I'm talking today about Consul, connecting your services together with Consul, and talking about doing that inside Kubernetes and outside. Now, it's going to be fun. Most of what I'm going to show you today is going to be a live demo, so we'll see how that goes. And it's going to involve Kubernetes and cloud providers. So hopefully this is going to be good fun and going to go well. But just before I jump into that stuff, I just want to give a little tiny overview of kind of the problem space and what it is we're talking about here. Now, actually, Mitchell has kind of set the stage really well in the keynote just there, talking about the problems of service mesh and what connectors to solve. But I want to kind of define what this kind of new term service mesh means a little bit more crisply. So to take a step back, the big problem statement, and we've already heard about it in the room this morning, so this will be super quick. It's about infrastructure becoming more dynamic. And for service communication, the big problem with that is IP addresses are not kind of static, long-lived things that you can kind of insert into firewall rules, that you can hard code DNS entries for. And so you have these three problems that we talked about before in the keynote, where how do you discover where these kind of more ephemeral services are running? How do you secure them when you kind of traditional networking firewalls are kind of just can't keep up with the dynamism you need? And how do you manage configuration amongst lots of distributed instances? How do you have them all see the same kind of consistent state of the world for how they should be behaving? And actually, all three of these things are a configuration problem. You have a source of truth about what should be running, where it should be running, what should be allowed to talk to what, and how your application should behave. And the challenge is, how do you have this update programmatically, and how do you distribute those updates efficiently through a large cluster? So the spoiler alert is this is Consul's core feature set. So this is what we're going to be talking about this morning. I was promised a pink room, but sadly we didn't make the pink. But I want to hone in a little bit more. Yes, I'm such power. Oh, I feel giddy. OK. We want to hone in a little bit more and define what this thing is called service mesh. So service mesh is one particular class of solution to this set of problems that we've just discussed at a high level. There are other solutions. And Consul itself kind of supports a wider range of solutions than just this definition. But I want to just kind of hone in on what we tend to mean when we talk about a service mesh. And that is specifically that we're talking about an infrastructure layer which sits above your network and below your application. And it solves this connectivity problem at that level. So there are solutions like gRPC, Apache Thrift, many other kind of frameworks for building services that solve some of the discovery. They solve some of the kind of reliability in communicating and load balancing. And they do that in the application. You build it into your app. So that's kind of an alternative solution. And on the other hand, there are software-defined networking solutions which solve some parts of this problem space too, like securing different workloads right in your network. But service mesh is an approach where you actually pull it out of both of those. You're agnostic to the network below you, so you're not concerned about how bytes or packets get from one host to another. But you're also outside of the application. And the way that works is that you deploy a service mesh typically as a proxy, which is co-located. It's a separate process that's co-located alongside each application process. And these two can talk to each other over loopback interface, which, as Mitchell mentioned, is generally very performant. But the benefit you get here is that all of that logic about how to discover services, how to route them, configure themselves, et cetera, is separate from your application and can be deployed as a separate unit. So typically, you have a separate infrastructure team who are responsible for deploying your service mesh. And they can deploy a new proxy and update that without having to kind of coordinate with application teams to get a new build out and all that sort of thing. So that's the real benefit of this kind of external proxy approach. And the proxy, we kind of mentioned, but it abstracts all of these, a lot of kind of patterns around resilient communication between your services. So the obvious one is load balancing, but also things like retries on error and circuit breakers when you do have errors to kind of route around failure. These can all be handled in your proxy, and then that's logic that you don't have to either code libraries for all of your service languages or kind of rely on something else to re-implement everywhere. The other benefit you get with this approach is that you can instrument the proxies themselves, and you can have a consistent way to see request rates, error rates, latencies, who's talking to who across your entire infrastructure without having to coordinate between different application teams to kind of instrument all their various applications in a consistent way. And then the final thing to note, Mitchell already mentioned it again, there's two distinct components within the service mesh. The control plane is kind of the source of truth. This is the distributed system that worries about what should be happening, and it distributes those updates through your cluster. And then the proxy itself is the data plane. So all your application traffic just flows through that proxy. And it's important to note that the service mesh solution as a whole should be resilient. So if the control plane has an outage, so if all your Consul servers go down, you don't want all of your application traffic to stop. And it won't in this case because it's only the proxies themselves that are forwarding that traffic. So that's kind of service mesh defined in a nutshell. I want to move on and talk about Consul and Connect and Kubernetes all together. And Mitchell's already kind of set out a lot of the case for this, but our goal with Consul really is to make this kind of solve these service connectivity problems, but for any platform that you're running on. So this isn't us saying Kubernetes is the new way to run Consul. You should all do that. This is saying if you're using Consul, Kubernetes should work really well for you in that environment as well as all your other environments. So I'm going to demo this. We're going to show some of the work over the last couple of months that just got announced for integrating with Kubernetes. The first question that might come up is, doesn't Kubernetes kind of solve all these problems already? Why would we need to use Consul as well? And the answer is, it mostly does, yes. The discovery and configuration are built in. You get those out of the box. And it has network policies for security. You do need a separate controller layer, something like Calico, that will actually enforce those policies by configuring IP tables, for example. But the key thing here is that these solutions only work for your Kubernetes workloads. We've just heard about all the many reasons that we see customers, even the ones who are kind of all in on Kubernetes, their reality is not 100% Kubernetes. And even with best intentions, there are usually many reasons for having some workloads that are just never going to make sense to run in Kubernetes. So we want to build a tool that is going to work great there, but it's going to also work great in all your other environments that you have to run things. And even better, work seamlessly across the two. So we're going to show a bit of that today. So we're going to get right into some demos in a minute, and this is kind of the moment of truth. But just before we do that, just before the fireworks begin, I just want to show you kind of visually what we're going to be installing here. So the first thing we want to do is install Consul on a Kubernetes cluster. I should say, like, if you're not super familiar with Kubernetes, then that's cool. Hopefully, you'll take something away from this demo. I will mention a few details, just for those who are a bit more familiar, but I hope the kind of the overall story is kind of clear anyway. So please excuse me for not kind of explaining every detail as we go through. So the first thing Mitchell talked about a month ago, we released our official Consul Helm chart. Now, Helm is kind of like the package manager for Kubernetes. It packages up complicated applications into the resources needed to run them on Kubernetes. And so we're going to use that to install Consul. And what it's going to look like, because it helps to kind of have this in your mind once we start looking at the UIs, is this. We're going to have a 5-node Kubernetes cluster. And Helm chart is going to install a Consul client onto every one of those nodes. And then it's going to install 3 servers. We use 3 because they store state in a strongly consistent way with the Raft consensus protocol. So you need 3 to be tolerant of 1 failing. They're going to end up on any 3 random nodes. I don't know where. A slight quirk is that here we're going to end up with a client and a server on the same host. That isn't typical. If you deploy this by hand in a data center, you generally wouldn't do that because the servers are also clients. But Kubernetes doesn't actually currently give you a way to express, I want something to run on every machine except the machines that these 3 things are running on. So it doesn't matter. Consul doesn't mind, so that's how it's going to look. And the really key thing I want to note here, though, is that the client agents are installed per host. They're not inserted into every pod or every network namespace container. They are per host. And if you want to talk to them from your app to consume the API, you can do that using the host IP, and Kubernetes can make that available to your pod. So that's what we've got. Who's ready for some demos? I might need some encouragement if this doesn't work. So what we're looking at here, if you've not seen this before, this is Google Cloud Platform. We're doing this on a real cloud, guys. Please don't start downloading things using up all the interwebs. Let's just check I've got internet. Here we go. It's looking good. So we already have our Kubernetes cluster set up. Of course, that was just a single Terraform command. I could have done that live too, but it takes a couple minutes, so I didn't. We have 5 nodes. That's what we wanted. And then if we look here, there are no workloads. So nothing's running on this cluster. And there are no services defined so far. So it's an empty Kubernetes cluster right now. So the first thing we're going to do is install Consul. And I just want to show you a little bit of config with my fancy cat alternative. Here we go. So the Helm chart itself, by default, with no config changes, will get you the Consul cluster we just looked at. But there are just a couple of features and options that we want to enable for this demo, and I'll just show you really quickly. One is we're going to have a cloud load balancer just to make it easy for me to connect to the UI without setting up port forwarding and things. You probably don't want to do that in production and just expose your Consul UI to the public. Next, we're going to enable catalog sync. And this is cool, but I'll come back to that later. Next thing, we're going to enable Consul connect, inject. And this is the thing that's going to inject, connect Envoy proxies into into any pod that requests it. You can have it do it by default, but we're going to have to opt in here. And lastly, this is just a bit of housekeeping. Envoy requires a gRPC API, and so we just have to enable that because it's not on by default. So I should be able to just do Helm install and then those values. I'm going to give this a name. I'm just going to call it Consul. This is just Helm. If you've not used it, picks a random name if you don't give it one, and that bugs me. So, and then really soon, our official Consul Helm chart will actually be adopted by the official central Helm repository, and so you'll just be able to do this by name, and it will know where to go and download it. Right now, they're working through some issues, so I'm just going to do this from the Helm chart that I've got checked out right here on my machine. So here we go. Let's see if it works. So there we go. A bunch of stuff happened. We'll go and see what it set up. So these are the workloads in our cluster now. So it's done something. We have a couple warnings. Things are still coming up and getting healthy, but we'll talk through that. What we can see is Consul. This is the client agents, and they're running as a daemon set. So that means one per node in your cluster, and there are 5 of those, like we expect. We have the servers here. We have 3 of them. They're actually a stateful set, because Consul servers store state. They're just coming up. This is good. And then you can see we've got 2 other services running here already, 2 other workloads. One of those is the webhook that enables that connect inject feature I was talking about. And this bottom one is the catalog sync, the mysterious catalog sync. And again, I will come back to that in a minute and show you what it's doing instead of just telling you. So finally, we've got some services. And because we added that load balancer thing to our config, it's created a load balancer, and it's already got an IP address, which is good. This is the thing that can sometimes take a while. And so you can see 3 healthy console nodes, and the UI is available to us, and we're all good. Phew. The other cool thing we can see right here is that console UI service. Who registered that? Well, this is the mysterious catalog sync. That is the Kubernetes service that we created to expose this UI through a load balancer. And because it's an externally accessible service, the catalog sync service has automatically registered that in Consul for us. And that means that anything outside of Kubernetes that is using the same Consul cluster can discover and access that service just using Consul's regular service discovery. So that's cool. So next up, we have Consul running, but we want to deploy something. So I want to run a demo app to show you kind of how this works, how Connect works. But before we jump straight to connecting it up, we're just going to install it on the Kube cluster without Connect first. And so our app here is called Emojify. We'll see what it does in a minute. It's quite fun. And this is the architecture we're deploying. We have 4 different services. The ingress service here is an Nginx. It's just an Nginx container, and it's just going to do basic path-based load balancing and routing. It's routing / to the web service. I think it's actually called website in Kubernetes. And / API is going to the API service. And then the API service is a Go HTTP service, and it's going to consume a mysterious backend, which is called Facebox. If I say Facebook by mistake, then please ignore me. So this is what we want to set up, and we're going to come right over here and see that. So I have all the YAML. So these 4 files contain all of the Kubernetes resources we need to set up this app. I'm not going to show them to you right now. We will take a look in a minute. But let's just see. All I have to do is kube control apply and give it a directory, and all of the resources and all the YAML files in that directory are just going to get created in the cluster for me. OK. So if we come back here, we should see a bunch of new workloads. These 4 Emojify workloads have turned up, and they're OK already. And we should see some new services. And here we've exposed another load balancer, so we should be able to load up our app as soon as this load balancer is provisioned. Now, this is the bit that can often take a while. Google Cloud takes sometimes a few seconds, sometimes 30 seconds or so to get the load balancer up. So we're going to wait for that. There it is. And then hopefully it's going to load straight away. There we go. So we have our app, and it's up. So let me just show you this app, because this is pretty fun. So this is the website. It's a single-page React app, and it's being served by that website service. And then when we enter an image in here, it's going to submit that to the API service through our end. So I'm just going to go and grab a picture of my favorite band. As a test for anyone who grew up in Britain in the 90s. And we're going to submit that. And after just few seconds of loading, we should find that all the faces in the image have been detected by this Facebox service, which is using some machine learning models to detect faces. And then our backend has replaced them all with random emoji. So that's pretty cool. That's working. But just to recap, this is all just using standard Kubernetes service discovery. So our challenge now is, how do we use Connect to connect these services together? All of these services are exposed to the whole data center at the moment. So I have an alternative set of YAML files here. Don't you just love YAML? You can't get enough of it if you work with Kube, anyway. So I just want to show you, I'm not going to show you the diff for the whole lot because it's kind of repetitive, but I'll just show you one of just the API service, the changes to that. This is the one sitting in the middle. Remember, Nginx is talking to API, and then API is talking to the Facebox service. So the first change here is we don't have a Kubernetes service definition anymore. This is because we just don't need Kubernetes service discovery for the actual app. I could have left it in. It doesn't make much difference. But we're going to remove it, and we'll see why in just a second. And then this is all the rest of the changes to this service here. You can see we've added a couple of annotations. That first one is just opting us in. It's saying, please inject an Envoy proxy into this pod so I can use Connect. The next one is config for the proxy itself. It's saying the local app's running on 1990. And that's the same thing you see down here. This is the argument we're passing to the binary to listen on 1990. And then there's the last one is saying to the proxy, we need to speak to the Facebox service to consume that. So that's here. And then we want that Facebox service to be mounted locally on our loopback interface on port 8002. This is pretty much a random number. The only thing that cares about this is this line down here. So this is only accessible inside the pod, inside the network namespace that's running this service. So as long as these two things match, we're good. And then you can see that the URL that we used to be giving for Facebox was using kubedns. This is Kubernetes kind of service discovery mechanism. But we don't need that anymore. We just need to talk to localhost 8002. And then finally, we no longer need to bind to all interfaces. And we only bind the actual service to localhost as well. So nothing is going to be able to access this service unless it's going to come through that Connect proxy. And the Connect proxy is going to enforce mutual TLS and authorization. So I'm going to apply this. And then we can go and watch the workloads all restart. Hopefully, they're usually pretty quick. The ingress takes the longest because there's a couple of them, and it does rolling restarts. We just need to wait until the old one's gone. This pod's still initializing. You can see the revisions here. This will still work, by the way. The app is still up. I just want to make sure I'm definitely hitting the new thing that's using Connect before we move on. We can actually see, if we reload the app, it should still be working. So we're good. And I'm just going to wait until that's good. Everything there is still happy. This is the fun bit of live demos. At least it's all working so far. Just got to fill the dead air. OK, well, so I could carry on here, and we get a 50-50 chance, right? We have one ingress that's running the old version without Connect, and one that's running the new one right now. So shall we play roulette? See if the rest of it works? Actually, one thing I can do is just go and... You didn't see that bit, right? OK, so now we just have one instance of this thing running, and it's the new one. So Except it's not. Kuber's too clever for me. It's beaten me. So, any minute. OK, I'm going to talk through the next bit, and then we'll see if it works. And hopefully, by the time I've talked through it, it will. So, this is probably now running using Connect, right? But you can't see any difference. Maybe that's because we're hitting the instance that's not using Connect yet, but maybe that's because Connect's actually working and is allowing all by default. But we can demo that it does work by coming, this is back in the console UI, and we can create an intention that explicitly denies, if I can type, denies all traffic that's going between the ingress, that Nginx, and the website. So if we create that, then instantly you get a 502. This is an expected error, guys. You should be happy about this one. Yeah. So this is Nginx. Thank you. Thank you. This is Nginx attempting to connect to a website instance, and yet the proxy in the website instance is saying, sorry, you can't connect. The authorization call to Consul is failing, and so it's just dropping the connection. And so Nginx can't get a connection to any of the backends for website, and so it's giving you a 502 back. So this is showing us that Consul's intentions are working. And as soon as we delete that intention, I didn't mean to do that. That'll do. As soon as we delete that intention, everything comes back up and we're working again. So this is showing you that Connect is now securing and controlling access to every one of those 4 services, and they're all now encrypted on the network. OK. So we've seen how to add Connect to an existing Kubernetes app. And it was all right, wasn't it? It was just a couple of lines of change to inject that proxy and to configure it. But the whole kind of theme we've had going through the keynote is about how do we have a great experience on Kube, but also a great experience on all the other platforms as well. So the final part of this demo, we're going to integrate some legacy. So the story goes like this. You've built Emojify in your spare time, and you take it to show your boss. And he's really, really excited. And he looks at you with a gleam in his eye and says, how do we make some money from this thing? Right? I've got it, he says. We're going to sell prints of these wonderful, wonderful artistic creations. And your heart sinks at this idea. Why? Not because prints is a bad idea, because clearly everyone wants prints of emojified faces. Your heart sinks because that means you have to talk to the legacy payments API, right? And the payment service is this box in your data center. It's attached to your merchant's point-of-sale device with a serial cable. Like, there's no way that thing's ever going to make it into Kubernetes. But even worse, last time you had to integrate something with payments, it took you 3 months and, I don't know, 5 Jira tickets just to get them to open your firewall port to that box. And that was just for one IP address. You're now asking them to open the IP for every IP in the whole range that any pod in Kubernetes could ever have, because you don't know where this is going to end up landing. So we're going to see how Consul can maybe help you with this. It maybe can't help you deal with Jira tickets, but we'll show you the rest. So this is what the new architecture is going to look like. We're going to have the same app running in Kube, but now the API has to talk to a payment service, which is outside. And playing the part of this legacy payment service is this VM I set up over here. Ladies and gentlemen, this is SSH on a real VM in a Kubernetes demo. And just to, I mean, this isn't really legacy. This is an Ubuntu box. It's using systemd. You have to use your imagination a little bit. But just to help you along, we've built a genuine Java Spring Boot API for this payment gateway. This is what we have to talk to. And I'm just going to start a couple things off here, and we'll see what that is. So what I've just started there is another couple of systemd units. One of them is going to run us a Consul agent on on this VM that's outside of Kube, but it needs to join the Consul cluster that's inside of Kubernetes, the one we installed just now with our Helm chart. And instead of trying to figure out what the IP addresses are going to be for that thing, we can just use the new Kubernetes discovery built into Consul. And what this is doing is we've given a read-only access credentials for the Kubernetes API and drop them on this box. And then all you have to do is specify you need the Kubernetes provider and which label you need. So it's going to select all pods that have app, console, and component server. And it's going to find the IPs of those, and then it's just going to connect to that automatically. The other thing we ran was a Consul Connect proxy. And the fun thing to note here is that this is the Consul binary. This is the built-in proxy. This is not going to be Envoy, but it's going to be talking to Envoy on the other end. So this is showing you it's just mutual TLS. As long as they are built the right way, they can talk to each other. And we're using the built-in one because it has a couple of nice features. You can just tell it what service you want to represent. You can tell it where you want to listen. And then you can even have it register in Consul for you, which just makes this demo a little bit easier. So with any luck, and this bit has gone wrong a few times now in rehearsals, there we go. We now see both the payment service and its proxy registered in our console. Remember, this is the Consul cluster running inside Kubernetes, and our workloads outside Kubernetes have just been able to discover and register. But even more fun than that, do you remember that catalog sync feature we turned on? Well, it works the other way, too. So you can see down the bottom here, the payment service and the payment proxy are now showing up in in Kubernetes. And they have this Consul true label. That means that anything running inside your Kube cluster can now use native Kube DNS discovery to discover the IP of that thing that's running outside of Kubernetes. OK, so we have our payment service. We now need to change our app to use it. So I'm just going to once again just show you the diff on the API config. And oh, I'm dangerously close to out of time. So let's see how this goes. So all we have to do here, the only change is we're adding a new upstream, right? We're now saying we also need to be able to talk to the payment service. And we're just picking another port, 8004. That's wrapped, unfortunately. But there we go. And then the only other thing is we're just configuring the API itself. Your payment service is now on localhost 8004. It's worth noting here that this is no different. In your config, it looks no different that we're connecting to something outside Kubernetes as inside. It's all in Consul, and it's all the same. So here we go. It's gone almost too well so far. Let's see if this last bit can work for us. So we should have, green already? Not green already. There we go. So we're restarting that kube pod, and that may or may not be a good sort of error. Let's see. We can come back here anyway and see when it reloads. OK, not yet is the answer. I'm just going to go check out this error. That's a new one on me. Oh, I didn't want to learn more, thank you. You often see errors like this. Oh, this is the old one that's erroring, so I think we're good. We should be good in just a second. So we're just waiting for the config map for the website service to update, which can take a while. And looks like I could be out of time to show you, which is unfortunate. So it's there. So our payment service, sadly, it's not there. So we should see the upgrade to Emojify Enterprise. And we should be able to go through this whole flow and then buy a print at the end. Sadly, I'm out of time. I'd love to finish this demo if anyone wants to drop by the Consul booth. But let me just wrap up really quick. So what we did here we installed Consul clients and servers on an empty kube cluster. We deployed an app containing 4 services on it. We upgraded those so they could use Consul Connect to secure all their traffic. And then you didn't quite see it, but honestly, we did use Connect to secure that legacy service. Thank you very much.